Hello everyone, welcome to Bodhi Academy. In this video, you will learn 1 and 2 mark question from the matrices and determinant chapters. So, first of all, let's solve some MCQ type questions, 1 mark. So the first question is, this matrix is given A, and the option is identify this matrix means that is the question. It is symmetric matrix, skew-symmetric matrix, singular matrix, or non-singular matrix. So when we say the matrix is symmetric, when the matrix is same as its transpose, then it is called symmetric matrix. When we say the matrix is skew symmetric, when the matrix is same as minus of its transpose, then it is called matrix is skew symmetric. The third option is singular. So when the matrix is called singular, when its determinant is equal to 0, and when we say the matrix is non-singular, when the determinant is not equal to 0. So this is the properties. Okay, now in this matrix, look at this. These entries are 0. This is called the diagonal elements. Whenever in the matrix the diagonal elements are 0. Okay, and one more thing, look at this element. This element and this element have equal numbers but opposite sign. Again, this is for minus 5 and here it is 5. Here it is 3, here it is minus 3. Okay, so it is satisfying this property. A is equal to minus of A transpose. So this matrix is nothing but skew symmetric matrix. Okay, when we say it is symmetric, when this element and this element both are equal. Okay, so just remember how the skew symmetric is look like. Skew symmetric is look like this kind. Diagonal elements are 0. If suppose here it is A, then this element is minus A. This element is B, then this element is minus B. Here it is C, then it is minus C. Okay, this is how the skew symmetric matrices look like. And symmetric matrix. Symmetric matrices look like this kind. In the diagonal, it is not necessary it will be 0, but whatever element is here, the same element is here. Suppose here it is F, then here it also F, here it is G, then here it also G. Okay, these elements should be equal, then it is called symmetric matrix. Okay, diagonal can be anything. And skew symmetric matrix, diagonal elements are 0 and this element have a same number but opposite sign. Okay, so the correct option is B for the first question. Now look at the second question. Now it is already given it is skew symmetric matrix, then what should be the value of x? That is the question. Okay, so how it is look like that I already told. Here it is suppose and whatever element is here, okay, the same element should be here but opposite sign. So in this matrix here it is x, so which value will put here? So we'll get this matrix is skew symmetric. So look at this element, this is minus 1, so it is a choice for x here 1. Okay, opposite sign we did in skew symmetric, so correct option is C. Come to the next question. Yeah, this question. Identify this matrix. So here it is 2, 6, 0. Diagonal is anything. Now look at this number. Here it is 3, here it is also 3. Here 5, here also 5. Here minus 1, here it is also minus 1. So it is called, it is nothing but symmetric matrix. Okay, this is called symmetric matrix. One more type, diagonal matrix, we just remember how the diagonal matrices look like. Okay, this is how symmetric matrices look like. This is skew symmetric, it is look like. And diagonal. Diagonal matrix means in the diagonal element is non-zero and the remaining element is 0. This is how diagonal matrices look like. Okay, and two option was there, singular and non-singular. So when we say the matrix is singular, when the determinant is equal to 0, then the matrix is singular. And if determinant is not equal to 0, then it is called non-singular. And remember two more things. If the matrix if determinant is 0, that means matrix is singular. That means the inverse does not exist. Inverse does not exist if the determinant is 0. If determinant is non-zero, that means if matrix is non-singular, then only the inverse of the matrix exists. Okay. The next question is based on this result only. So this matrix is given. This matrix have no inverse. no inverse. So in which case we will get no inverse does not exist when the determinant is 0. Okay, so we have to find out the value of k for which determinant is 0. So whenever the determinant is 0, in that case only the matrix has no inverse. Okay, so we will find out the determinant k 2 3 4. Let's take it is equal to 0, because whenever determinant is 0, in that case only the inverse does not exist. So k into 4, that is 4k, minus 3 into 2, that is 6, is equal to 0. So what we'll get from here? 4k is equal to 6. So k is equal to 6 by 4. So if we cancel out by 2, 2 3s are 6 and 2 2s are 4. So the value of k is nothing but 3 by 2. That is correct option is D. So for k is equal to 3 by 2, the inverse of this matrix does not exist, and remaining, if the question is for which value of k the inverse exists, then accept this value, the inverse will exist, or this remaining 3 value. Okay. For the k is equal to 3 by 2, we will get determinant is 0. So for this k is equal to 3 by 2, inverse does not exist. Okay, now come to the next question. This question I have taken from your just now recent your prelim examination. Okay, so matrix A is given, matrix B is given. We have to find out A transpose into B. So what is the meaning of transpose? A is given 1 3 2 4. Okay, so we have to find out first of all what is A transpose. A transpose means we have to write down row into column. So what is the first row? 1 3. So that we will write down in the first column 1 3. Second row is 2 4. So that we will write down in the second column 2. Okay, into we need B. This question I have taken. This is just previous year board question paper. Okay, and B is we have 2 3. So we need to calculate A transpose into B. Multiplication. A transpose multiplied by B. So remember one thing, when the matrix multiplication is possible, so what is the order of A transpose? 2 by 2. What is the order of B? 2 by 1. 2 rows, 1 column. So look at the number of column of the first matrix, that is 2, and the number of row of the second matrix, that is also 2. So these two numbers are equal, then only we will multiply the two matrices, otherwise not. Okay. So now how to multiply the first row into first column? So first row we have to multiply with first column. So 1 into 2, that is 2, plus 2 into 3, that is 6. Then there is no other column, so now take the second row and multiply with the first column. So 3 into 2, that is 6, plus 4 into 3, that is 12. Okay, so this two number will tell you if you can multiply the matrix or not, and the remaining two numbers, 2 and 1, that will give you the order of the resultant matrix, that is 2 by 1. So the resultant matrix we will get 2 by 1. Okay, you can see that here 6 plus 2, that is 8, and 12 plus 6, that is 18. So this is our answer of A transpose into B. So our resultant matrix is 2 by 1. Come to the next question. So the next question is find the value of A if this matrix is singular. So when we say the matrix is singular, if the determinant of that matrix is 0, then okay. So the result is matrix is singular, that means determinant of that matrix is 0. So 2 3 5 1 A 2 0 1 minus 1 is equal to 0. Determinant is equal to 0, then it means it is singular. Okay, so we'll solve the determinant. So how to solve determinant? 2, then here A 2 1 minus 1, then minus of 3 1 2 0 minus 1, plus 5 1 A 0 1 is equal to 0. Okay. So 2 here we will get A into minus 1, that is minus A, minus 1 into 2, that is 2, minus 3, 1 into minus 1, that is minus 1, minus 0 into 2, that is 0, plus 5, 1 into 1, that is 1, minus 0 into A, that is 0, is equal to 0. Okay. So if you multiply this 2 here inside, so it becomes minus 2A, 2 into minus 2, minus 4, here minus 3, minus 1 minus 0, that is minus 1 only, plus 5, 1 minus 0, that is 1, is equal to 0. Okay. So minus 2A minus 4, minus 3 into minus 1, that is plus 3, 5 into 1, that is plus 5, is equal to 0. Now just solve the number. Minus 2a as it is, minus 4 plus 3, that is minus 1 plus 5. So minus 1 plus 5 is nothing but 4. So minus 2a plus 4 is equal to 0. So if we take this 4 that side, so minus 2a is equal to minus 4. So 2a is equal to, minus minus will get cancelled, 2a is equal to 4. So a is nothing but 4 upon 2, that is 2 to the 4. So value of a is 2. Okay. Come to the next question. So in this next question, the question is find the value of x and y. These matrices are given. So outside the first matrix there is some number. So first of all we have to multiply this number inside the matrix. So it will get 2x, 5 2s are 10, 14. If you multiply this 2 inside, so this become 2y minus 6 plus this matrix as it is 3, 1, minus 4. This is also as it is 7, 6, 50, 40. Now just add this matrix. How to add the matrices? Corresponding element with corresponding entry. Okay. So 2x plus 3, that is 2x plus 3. Then 10 plus minus 4, that means 10 minus 4, that is 6. Okay. Then 14 plus 1, that is 15. And 2y minus 6 plus 2. Okay, so 2y minus 6 plus 2 is equal to this matrix 7, 6, 15 and 14. Now between these two matrices we have sign that is equal to. That means these two matrices are equal. So when we say the two matrices equal, when their corresponding entries are equal, that means this 2x plus 3 is equal to 7. Okay, so we will write down here 2x plus 3 is equal to 7. So from here we will get the value of x. 2x is equal to 7 minus 3. So become 4. 2x is equal to 4. So x is nothing but 4 upon 2, that is 2. Now we need y. So y is here. So compare this entry with 14. So 2y minus 6 plus 2, minus 6 plus 2, that is minus 4, is equal to 14. Okay. So take this minus 4 that side. So 2y is equal to 14 plus 4. So 14 plus 4, that is 18. So 2y is equal to 18. So y is equal to 18 upon 2, that is 9. Okay. So the value of x is 2, the value of y is 9. Come to the next question. This was your recent prelim examination question. A is given, B is given, we have to find out A transpose plus B. So A is given, so what is A transpose, that we will find out first. So A transpose is nothing but change row into column. So what is the first row? 1, 2. So let's write in the first column 1, 2. Second row, that is 3, 4. So 3, 4 will be here. And B is as it is. What is B? B we have 1, 2, 3, 4. So we need to calculate A transpose plus B. So A transpose plus B is equal to A transpose is 1, 2, 3, 4, and B is also the same thing 1, 2, 3, 4. So if we add these two matrices, so we will get 1 plus 1, that is 2, 3 plus 3, that is 6, 2 plus 2, that is 4, 4 plus 4, that is 8. So this is the answer of A transpose plus B. Come to the next question. So the matrix is given to be singular, we have to find out x. So we know that whenever matrix is given to be singular, that means the determinant of that matrix is equal to 0. That means 6 minus x, 4, 3 minus x and 1. Determinant of that is equal to 0. So now just solve this determinant. So 6 minus x into 1, that is 6 minus x only, minus 4 into 3 minus x, that is 4 into 3 minus x is equal to 0. So now this will be 6 minus x, and if you multiply this minus 4 inside, so it becomes minus 12, minus 4 into 3 minus 12, minus minus plus 4x is equal to 0. So this 6 minus 12, that is minus 6, and minus 4 plus minus x plus 4x, that is plus 3x, is equal to 0. So if we take this minus 6 that side, it become 3x is equal to plus 6. So x is nothing but 6 by 3, that is 2. 3 to the 6. Okay. So answer is x is equal to 2. Come to the next question. So in this question, two matrices are given to be equal and y is less than 0 given. Find the value of x minus y plus z. Okay, so two matrices are given to be equal, that means their corresponding entry is equal. Okay. So that means 1 is nothing but is equal to x. So from here we can say x is equal to 1 directly. Then 2 is equal to z. So z, the value of z is 2. Then 4 is equal to y square. Okay, or we can write down y square is equal to 4. Okay, so what is y here? Y is nothing but plus or minus root 4, and square root of 4 is nothing but 2. Okay, so value of y is plus 2 and minus 2. But it is in the question it is given that y is less than 0. That means y is negative. So we cannot take y is equal to plus 2. So the value of y is minus 2. We have to find out the value of x minus y plus z. X minus y plus z. So x is 1 minus y is minus 2 plus z is 2. Okay. So 1 minus minus plus 2 and plus 2. So 2 plus 2 4, 4 plus 1 5. So answer is 5. Come to the next question. So one matrix is given 2 by 2. We have to verify a square minus 3a plus 5a is equal to 0. It is satisfying or not, and hence we have to find out A inverse. So let's first of all verify this is equal to 0 or not. So a square, we have a, so let's find out a square first. A square means nothing but a into a. Okay, so a is 1 3 minus 1 2, again into a 1 minus 1 3. So how to find a square? By first row, first column. So 1 into 1, that is 1, then minus 1 into 3, that is minus 3. Then first row, second column. So 1 into minus 1, minus 1, then minus 1 into 2, minus 2. Okay. Then take the second row, first column. So 3 into 1, 3, 2 into 3, plus 6. Then second row, second column. So 3 into minus 1, minus 3, 2 into 2, plus 4. Okay. So if we solve this entry, 1 minus 2, 1 minus 3, that is minus 2, minus 1 minus 2, that is minus 3, 3 plus 6, that is 9, minus 3 plus 4, that is 1. So this is the value of a square. Now we need 3a. Okay, so we'll find out 3a. Let's take only 3a, not minus 3a. So 3 multiplied by a. A is given to be 1, 3, minus 1, 2. So just multiply 3 inside. So what will get? 1 into 3, 3. 1 into minus 3, minus 1, minus 3. 3 3 is a 9. 3 2 is a 6. So this is the value of 3a. Then the third is 5 into I. So 5i. I means identity matrix of order. Here it is a is 2 by 2. So I is also 2 by 2. That is 1 0 0 1. So if we multiply 5 inside, we will get 5 0 0 5. So we have to check a square minus 3a plus 5i. Okay. So what is a square? A square is minus 2 9 minus 3 1. After that minus 3a. 3a is 3 9 minus 3 6. Then plus 5i. So 5i is nothing but 5 0 0 5. Okay. So just add the corresponding entries. Minus 2 minus 3, that is minus 5. Then minus 3 minus minus plus. Okay. Minus 3 minus minus plus 3, that is 0. Okay. Then 9 minus 9, that is 0. Then 1 minus 6, that is minus 5. Plus the last matrix, that is 5 0 0 5. So if you add this matrix, minus 5 plus 5 0, 0 plus 0 0, 0 plus 0 0, minus 5 plus 5 0. So it is satisfying this. Okay, so half question is done. Now the second is find A inverse. Okay, So how to find A inverse? So the formula to find A inverse is nothing but 1 upon determinant of A into adjoint of A. This is the formula to find out A inverse. So matrix A is given to be, A matrix is given 1 minus 1 3 2, 1 minus 1 3 2. Okay. So we need two things, one is determinant and one is adjoint. Okay. So let's calculate determinant first. So determinant of A is nothing but 1 3 minus 1 2. That is 1 into 2, that is 2, minus 3 into minus 1, that is minus 3. So 2 minus minus become plus 3, that is 5. So determinant is not equal to 0, that means we can find out the inverse. Now adjoint. So adjoint of A. So for 2 by 2, we can find out the adjoint matrix directly. What you have to do? Just interchange this diagonal element. Okay, 1 will come here and 2 will come here. So this become 2, this become 1. Interchange the diagonal element and the remaining element just change the sign. Don't change the element, just change the sign. Plus become minus, minus become plus. So here it is minus 1, so it become plus 1. Here it is minus 3, plus 3 is given, so this become minus 3. Okay, so this is the adjoint. Now what is the formula for inverse? 1 upon determinant of A into adjoint of A. So A inverse is equal to 1 upon determinant. Determinant is 5. Adjoint of A, that is 2, 1, minus 3, 1. So this is the answer. Okay, thank you everyone.